In this video, we are going to take a look at a couple examples, actually 3 to be specific, about linear speed and angular speed. So linear speed is a distance traveled per unit of time, and angular speed is talking about the amount of rotation per unit of time. Okay. Now both linear speed and angular speed kind of have, or they have formulas that we work with, but when we talk about our linear speed, we are talking about it in terms of your angular speed. Okay, so they kind of go together. So we have a couple equations that we need to look at. First and foremost, our angular speed equation, okay, is going to be right here. So you have this funky looking W, which is omega, and then we have our angle divided by t. And the other equation we have is we have our linear speed, which again is in terms of angular speed. Okay, and here it's going to be your linear speed, which is this slightly V looking, and then times your radius and your angular speed. Okay. So here's just a couple examples where we're going to look at how to use these formulas in order to calculate the information we need. So our first one says we have a wheel with a 30 centimeter radius and it's rotating at a rate of 3 radians per second. You need to find the linear speed of a point on the rim in meters per second. So here's a couple of important things that you need to look at. First and foremost, my rotation is in radians per second and my radius is in centimeters. However, I want my result to be in meters per minute, which means we're going to have to do some conversions. Okay. The first thing we need to do is we need to convert your centimeters into meters. So in this case, we have our radius, which is 30 centimeters. And we're going to convert that to meters. So this would be 1 meter per 100 centimeters. When we do that, we end up with 0.3 meters. Now the other conversion that we need to do is we need to convert your seconds into minutes. So in doing that, I have 3 radians per second. And we're going to multiply that by 60 seconds per minute. So in this case, we're going to end up with 180 radians per minute. Once we get our 2 conversions, now we can actually look at the equations. So what do we have? Well, in this case, we have our radius, which is 0.3 meters, and we have our omega, which is 180 radians per minute, and we know that our equation is V equals the R omega, and this is what we're looking for. We want your linear speed. So in this case, we have that our linear speed is equal to my 0.3 meters times 180 radians per minute. So my linear speed in this case is going to end up being 54 meters per minute. Alright, let's look at another one. So here we have an industrial circular saw blade that has a 10-inch radius and spins at 1,000 RPM. The first part wants you to find the angular speed of a tooth in radians per minute. So again, we have a 10-inch blade and it's spinning at 1,000 RPMs, and we want to find radians per minute. In the second part, we want to find the linear speed in feet per second. Okay, so 2 different things that we're looking for. So the first thing that we have to know or remember is that 1 RPM is equal to 2 pi over 60 radians per second. So here I have 1,000 RPMs. So one of the things that I have to do is I need to be able to work my conversion here. And so I have my 2 pi over 60 radians per second. And I'm going to convert this into minutes because that's what I want, is radians per minute. So again, this is 60 seconds per minute. And so in this case, we end up with 120 pi over 60 radians per minute. And if we were to reduce 120 over 60, we would end up here with 2 pi radians per minute. Now with that, there's a few things that we know. We know that my speed is going to be 1,000 RPM. So in this case, we have to take that 1,000 RPM. Okay, so in order to find that angular speed, we're going to take that 1,000 RPM and we are going to multiply it by my radians per minute. So in this case, we're going to end up with 2,000 pi radians per minute as my angular speed. Now we also need to calculate the linear speed. So in this place, the first thing I need to do is I have to convert my inches into feet. So I have a 10-inch radius. So I'm going to convert this. So I have 10 inches. And I know that I have 1 foot per 12 inches. And so in my conversion, we're going to end up with 10 over 12 feet. We want to reduce as far as we can. So this is 5 over 6 feet. Okay. Now the other thing we need to do again is we need to convert our radians per minute. So I have 1,000 RPM. I know that its conversion becomes 2 pi radians.
Turns out Barry just moved into the apartment upstairs and thought the hot tub was for the whole building. Anyway, he's a super cool guy, he's straight, so there's no weirdness.
And so in this case, we're going to end up with 2,000 pi over my 60, which is going to reduce down to giving me 1,000 pi over 3 radians per second. Now with that, now I can actually convert my linear speed. So I have my linear speed, and this is going to be my 5 over 6 feet, and I'm going to multiply that by my 100 pi over 3 radians per second. And this is going to end up giving me 500 pi over 18 feet per second, which gives you the decimal 87.27 feet per second. Alright, the last example we have here is if we have a horse tethered and urged to trot such that it completes a circular path every 5 seconds. If the rope which tethers it is 20 feet long, what is the linear speed of the horse in miles per hour? So what we're looking for in this case is we want the linear speed, And again, we know that we need our radius and we need our angular speed. In this case, my radius is going to be 20 feet long, and in this case I want miles. So I have to convert my 20 feet into miles. So here I'm going to have my 20 feet, and I have mile and 5,280 feet. When we do that, we have 0.003788 miles. Now with this, I know that my angular speed is calculated by my angle over time, which in this case is going to be 2 pi over 5 radians per second. And here I wanted hours. So I have to convert the second piece over to hours. So I know there are 60 seconds per minute. And I know that there are 60 minutes per hour. So in this case, we're going to end up with 4,523.89 radians per hour. Now that we have our radius and we have our angular speed, we can calculate our linear speed. So your linear speed is going to be your miles. So 0.003788 miles times 4523.89 radians per hour. So in this case, we end up with 17.14 miles per hour. Alright, so there are 3 separate examples, all working with both linear and angular speed. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed these examples, and I look forward to seeing you next time.